So for this last little bit, we are going to do a little bit of statistics. And the first piece we want to talk about is describing distribution. So the opening exercise says students from River City High School were randomly selected and asked, how many pets do you currently own? The results are recorded below. So one person said 0, one said 1, we had 3, 2, 2, 0, 0, and so on. So those are all their answers. If I asked you to write what the typical number of pets was, you can't really tell this by just staring at all those numbers. So we can visualize this data with either a dot plot or a histogram, okay? So here's what a dot plot looks like, all right? So you kind of have yourself a little number line, and it looks like our smallest number is 0, and our biggest number appears to be that 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Let me move this line over a little bit here. 9 and 10. All right. And then what you're going to do is you're literally going to put a dot after each number as it occurs. So we have a 0, and we cross it out. We have a 1, cross it out. 3, cross it out. We have a 2 and another 2. So when we have another one of that number, you stack them on top of each other. So we have 2 more zeros. We have a 1, a 4, and so on. So you can see the process here, and it does take a little bit of time, all right? Crossing them out does help because it makes sure that you don't count anything twice, all right? And then, let's see, as we go here, we have a 7 and an 8. We have a 4 and a 5. And then we have 3, 2, 3. So it said we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So you should have 25 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Good. So the number of items you have should equal your number of dots. Now a histogram, okay, and let's label this actually. So this is there's our dot plot. And then our histogram is pretty similar in the fact that we need all the same information, but now we separate things into sections here. All right, and what we do essentially is we make little bars that are all connected for every one of our number slots. All right, so now what's the most amount of dots we had was here at 1, 1, 2, 3, 4, 5, 6. So we need to go 1, 2, 3, 4, 5, and 6. All right, so this tells you how many pets, okay, and this tells you the frequency, or in other words, how many people said that. So how many people said 0 pets? Well, that would be 5. So for the 0 piece, you're going to have a bar that says 5. How many people said 1? Well, that was 6, so you should have a bar for 6, all right? And normally you would color them in. We can just kind of like scribble in them a little bit here. And notice the bars are all touching. All right, that's big for histograms. At 2, you should have 4 pets. At 3, you should have 3 pets. At 4, you should have 2. At 5, you don't have any. So if you don't have any pets at that piece, that's where a break happens. Oh, excuse me, 5, you have 1. My fault. 5, you have 1. 6 is where your break occurs because nobody had 6. So 7's got 1. 8's got 1. 9's got 1. And 10's got 1. All right, so a histogram is really just a bar graph that's connected for all of your pieces. So the next two questions say, what's the mean number of pets and what's the median? All right, well, the mean is just fancy for your average. So you could add up all those pets, divide by 25, and that will give you your average. That's not too bad. Your median is your middle number. And that requires a little bit more work because you have to put all the numbers in order and then figure out which one's in the middle. Fortunately, your calculator will do both of these for you, but it's with a little bit of some different button pushing here. So I want you to go to your calculator, and then here, right next to the X button is a button that says Stat. Okay, so I want you to hit that Stat button, and then you want to click Enter for the first piece that says Edit, and you should come to a list that kind of looks like this, and ideally yours are going to be empty. Now, if you have any sort of random numbers in there, all you want to do is go up and highlight L1, hit the Clear button, okay, and then when you go back down, you'll see your list is empty. So what I'd like you to do now is we're going to type in the numbers. So what do we have? We had a 0 and a 1 were the first two numbers. So 0, enter, 1, enter. Then we had 3, 2, 2. So 3, enter, 2, enter, 2, enter. And I basically want you to go back and put in all those numbers from your list. So pause the video for a second because I'm going to take a minute to do it on my own. And then when you have them all on that list, restart the video. And then you should see when you get all your numbers in, that next line should say L126. So I know we only have 25 numbers. So that means it's waiting for you to put in the 26th number, and it tells us our 25th number is 3. So once you have all of those numbers in, you're going to hit that Stat button again. Now instead of clicking Edit to go back to that list, we're going to hit the right arrow to go over to Calc. And then since we only filled out one column, we're going to choose that very first option that says 1 bar stats. Now, if you have an older calculator, you're just going to see the 1 bar stats, and all you're going to do is hit enter. If you see this, like I have, you have to hit enter 3 times, and it brings up all these different crazy things. Okay. Now, I told you your calculator does this all for you in one step. So your average, the symbol for it in your calculator is an X with the line over it. So if we go back to our calculator here, that's the very first one. Our calculator says the average or the mean of this list. So on average, the people on this list have 2.8 pets. Now I get it, you can't have 0.8 of a pet, but that's not the big deal for right now. And then the middle or the median is the one that says MED. So if we go back to our calculator here, we might have to scroll down a little bit. You'll see MED stands for our median. So that is going to be 2, not 0.2, sorry, 2. So the middle, if you put all these numbers in order from smallest to greatest, the number that would occur right in the middle would be 2 pets, okay? And this median is really a better tell of what the amount of pets somebody has is than your average is, all right? Because if you look at this, we have that one person with 10, and then we have like one with 9, one with 7, one with 8. But if you look, where are most of our dots? Where are most of our tall histogram bars? They're all in the beginning, all right? So that average is a little bit higher because of those random people that have 10 pets and 9 pets and 7 pets. Okay, so this median value of 2 is a better tell for our data. So now when we talk about the distribution, there's a couple different words that we use here, all right? When your histogram or your dot plot looks like this, where it looks almost even on both sides, that's what is known as symmetrical, okay? It's balanced on both sides, it's known as symmetrical. When it's close to all being the same height, like in that top right-hand corner, that's called uniform, all right? So when all your data is almost exactly the same, that means your data is what is known as uniform. Now, here's where we got to be careful. When it seems like most of your data is all to one side, in this case, all left, so this data is what's known as skewed, all right? And in all this data here, most of it's on the left. So when we talk about how the data is skewed, it's actually skewed in the opposite direction. So this is actually skewed to the right, okay? Because the right side of this, we'll call it tail or bar, is longer than the left side. So if most of your data is on the left, it's considered skewed to the right. Where here, if you see most of our data is on the right-hand side, so then it's considered skewed to the left. All right, so it's always skewed in the opposite direction of where most of your data is. Now, the next thing I want to talk about is which of the following distributions has more variability in the data, okay? And that word variability basically means which one has the larger spread, okay? So when we talk about variability, we have spread. Now, if you see here, both the middles are at 6 and 6, okay? But look how much further this one goes to the left. This one goes all the way down to about 1 and all the way up to what appears to be somewhere around like 12, where this data goes down to maybe about 3 and then maybe about 9, okay? So this histogram on the left-hand side has more variability because it is spread out further from the center, okay? So here the center was 6, it only went from 3 to 9. Here the center was 6, but it went all the way from 1 to 12, all right? So the bigger the spread, the greater the variability. So 25 car owners were asked the age of their car in years. The results are recorded below. Create a dot plot to represent your data, okay? So they put everything in order for us. So you could use your calculator here. You could not. It's up to you. I would kind of like you to use your calculator. But for our dot plot, we've got a 0, we've got a 1, 2, 3, 4, 5, 6, 7, and 8. So what I'd like you to do is pause the video here and create a dot plot based on that information. So if we want to describe the shape of this distribution, well, all of our information is on the right-hand side. So therefore, it's going to be skewed to, and remember, it's always skewed away from its data. So it's skewed to the left because all the data is on the right-hand side. If we want to compute the mean and the median, I would like us to use our calculator again. So let's go back. On your main screen here, you can hit clear. So we're going to hit that stat button next to X. We'll hit enter for edit. All right, we're going to go up to L1 and we're going to hit clear. Do not hit delete. Okay, you must hit clear. And then if you go back down, you'll see your list is blank. So now if we look at our list here, we have a 0 and a 1. So 0, enter, 1, enter. Then we had 2, 2. So 2, enter, 2, enter. And what I'd like you to do is pause the video again and fill out the rest of this list based on the rest of the data. So when all your data is in your calculator, you are then going to hit stat. Instead of going back to our list, we're going to go over to calc using the right arrow, and then we'll take our 1-bar stats. So remember, older calculator, you just have to hit enter once. Newer calculator, you have to hit enter 3 times, 1, 2, 3. So our mean, remember, is that X with the line over it. All right, so the mean is X with the line, and our mean here is 5.84. All right, and you could have just added all the numbers up and divided by 25, and that would have given you that. Our median, which is that middle number, which because they put these in order, you could do this without the calculator, but that median there, that middle number is 7. Okay, so now we want to compute the standard deviation. All right, standard deviation basically tells us our variability that we just talked about. Okay, so our standard deviation tells us how spread out our data is. And the symbol in our calculator, and it's on that same list, it's a little funny looking O with an X. All right, so if you see right here, that little funny looking O with the X is going to be our standard deviation here, okay? And we'll do this, I don't think it says, so we'll take this to the nearest 10th, all right? So 2.4, okay? That gives us a little bit of variability in this data, okay? But that tells us how far things are away from our mean, okay? So on average, majority of the numbers are 2.4 away from that mean of 5.84. and then determine the range. So our range is our maximum value minus our minimum value, which you can see because they're in order, but your calculator also tells you. So if you scroll all the way down to the bottom of the list, it tells you the min is 0. It tells you the max is 8. So our range here is 8 minus 0, which is 8. All right. So that ability in our calculator to find our lists and be able to input those numbers in can tell us a lot about our data.